Hey everybody, and welcome back to Let's Practice. This is a fun one, okay? So this is the bonus lesson in which we're gonna learn how this quadratic function works. Okay, so let's see what we're gonna have here. We're gonna use an example, a private example, okay, not the general case. We're going to use a quadratic equations that precede some kind of a parabola, and let's see how we find out without the quadratic equation and without a trinomial what is the solution right here. Okay, so let's start. We're going to start by a little color coding. Okay, and let's divide this by 2. So first we want to get that the factor that precedes the x to the power of 2 is 1. Okay, this is the first one we want to do. And then we're going to color code it. This is going to be green. And this is a little bit weird. I need to explain this. And this is -8, right? The red one. Why did I choose this representation right here? Okay. What I have here, when I divide 4x by 2, I should get 2x, right? Actually, that's what we have here, but I chose to represent this 2x as a double 1x, okay? And the reason I did it will be clear in no time. So the next stage is to transport this -2 to the other side of the equation to get an 8. Now, let's think about this geometrically. Geometrically, let's say that each one of these terms is an area. This is an area that's equal to x squared. This is a double area of 1 times x, and this is an area of 8. Okay, so let's represent it geometrically. Here we have an area of x squared, which represented by a square of x on x, right? X times x equal to the area, which is x squared. Great. Now let's add up 2 rectangulars, which each side is 1 and the other side is x, like so. So this is the long side, x, and this is the short side, 1. And we're going to have it a double. We're going to have it twice, right here and right here. This is why I wrote 2 here. And all of that is equal to some rectangular, doesn't matter how exactly its area is 8, but let's just say that the area of it is 8. Okay, I don't know what this line and this line equal to. It doesn't matter. So this is what I got. Now let's take these 2 rectangles and put it on the square right here. After I do that, I'm going to get this situation. So I have a 1 times x rectangle right here, a 1 times x rectangle right there, an x square rectangle here, and 8 rectangle right there. Forget about that plus. It's not important right now. So I just moved things around, right? I didn't break the equality. It's still the same equality. Now I'm going to do a little addition, because I can add something to this side if I add it to this side, right? I still maintain the equality. So I'm going to add this rectangular right here. I'm going to add it here in a moment. So this rectangular, what is the area of this rectangular? Well, one side is 1 and the other side is 1, so the area of this rectangular, this square, is 1, right? So let's put it right here, and let's add it to the other side to maintain the equality. And let's also add it here, so we're gonna maintain the equality in the graphical representation we have here. So now this side is no longer x, this side is x plus 1. Right? And this side is x plus 1, meaning that all of this is a square that can be represented by the area of x plus 1 squared. And earlier we have an 8 and a 1, and now I put the 1 inside here, and now we have an area of 9. Cool. So the area here is x plus 1 squared, and the area here is 9, and it can be represented by this equation right here. Now, let's do a little bit arithmetic. By the way, this equation right here. This is a parabola that represents this equation. So what we have, let's do a root for that side and that side. Here we're going to get an x plus 1, right? And here we're going to get a plus minus 3. Okay, when you root 9, you're going to get a plus and a minus 3, because 3 times 3 is 9, but minus 3 times minus 3 is also 9. That's why you get both results. And this is the origin for that plus and minus right here that we have in the quadratic equation. Now let's put the 1 on the other side. Let's use the plus, and then we're going to use the minus. So we have the first solution is x equal to minus 4, minus 1, minus 3, minus 4. And the second one is minus 1 plus 3 is 2. So we saw how we can calculate the roots using a graphical representation, and this is the way they used to do it thousands of years ago. Now let's do the general case when we're going to use a generic quadratic equation. Okay, ready? Now we're going to deal with the generic case, okay? A generic quadratic equation. So this is going to be true for every quadratic equation. So we have this quadratic equation right here. And if you remember, the first thing we want to do, we want the factor that precedes x to the power of 2 to be 1. So let's divide this entire equation by the factor a to get that result, like so. Then, as you remember, we took the c factor, which is here is c over a, and we put it on the other side. And we represented this as 2 rectangles. So let's see what we get, and let's trace it out. Okay, so this x squared is this s squared right here. Great, nothing changed. Here we took the b over a and we changed it to b over 2a twice. Okay, if you multiply 2 by this entire thing, these 2 and these 2 are going to cancel out, and then we're going to left with b over a. So this thing represents 2 rectangles. This is the area of the rectangles twice. This is the 2 that represent that we're going to have this twice. Okay? So let's represent it geometrically. This is the x squared, right? Here we have the 2 rectangles, 1 and 2, represented by these 2 here, which one has one line, which is one line of the rectangle, which is b over 2a, and the other one is x. Okay, that give me the area of this entire purple rectangle, and we have it twice. Lastly, all of that is equal to a rectangle, which is area is minus c over a. You say, how this is possible? How can an area be negative? Don't worry. This is going to be negative, or this is going to be negative. That will cancel out this negative right here, and all of that's going to be positive. Okay, so don't worry about it. Now, as we did earlier, we're going to take these 2 rectangles right here and going to put them here and here. And after that, we're going to get this result. So what we have here, as you can see, we have almost a square, but we want to add that little blue square right here to make it a complete square, right? So this is what we do. We're going to add it, and we're going to also calculate what this square area is. So we have one line is b over 2a, the second line is b over 2a, so the area, total area, is going to be b over 2a squared. So now we have a complete square here, and this line, it was x, but now it's x plus 2 over 2a, b over 2a, and this one used to be x, but now it's also x plus b over 2a. But before we forget, we added this square right here, we need to add it right here in order to maintain the equality, like so. And after that, let's plug this area inside the red area to get, this is the area of this square right here, because this is one line and this is the other. And we're going to add it inside. Now we have a different area right here. Now let's write what we did. We know that we maintained the equality all along, so we can write this area equal to the total area right here. And we're going to get this expression. That's it. This is a quadratic expression. We just need to move some things around and use some algebra and move it, and we're going to see that we're going to get this shape in the end. So let's do that on the next slide. Great. So here we have what we had earlier. Now let's do some little algebra. Okay, let's start by applying a square root here and here, and we're going to get this situation right here. Now let's move this b over 2a to the other side. By the way, here is the plus minus that we have in the quadratic equation. This is the origin of it. So let's move b over 2a to the other side, like so. Now this is where the minus b where the minus b came from this minus that we just gained. Now let's see. Here I have a situation. If I'm going to multiply the top one by 4a and the bottom one by 4a, which give me a complete multiplication by 1, that doesn't change this c over a fraction, I'm going to have the same denominator, just like so. Now I have the same denominator. I can add these two fractions together to get this result. And now see what we have here. Here we have the determinant, right? I even made it brown like earlier. Now I have a common denominator right here that can be square rooted, right? Because square root of 4 is 2, and square root of a to the power of 2 is a. So we can put it outside the square root, right? Just like so. And let's put the determinant right on top of it, right? Like so. And we have the same denominator here and here. And then we finally have the shape of the quadratic formula like we always knew it to be, right? Isn't that cool? Isn't that awesome to see why it works? And it's awesome things. And mathematics is full of these little beautiful stories, full of it. I hope you're going to enjoy it when next time you're going to use the quadratic formula. Maybe try to show it to your friends and make it look like you're geniuses or something like that. So great. So this was the bonus lesson for a single variable quadratic equation on the subject of the quadratic formula, right? So I'm going to see you in the next one, practice number 5. It's going to be the last one, and let's see you around. Bye guys.